Hello everybody, very important lesson today. This is a mini proof lesson, but it's going to be incorporated into bigger proofs. It could be your 6-point Regents question, it could be your 4-point Regents question. It's not really hard if it's practiced. I can complete multiplication mini proofs by working backwards to proportions to similar triangles. I'm going to quickly show you why we do the process we're about to do, but I want to focus more on how we actually do it. If I have similar triangles, so if I have that triangle ABC is similar to triangle DEF, there's my triangles ABC, DEF, and let's say I have 2 and 4 and X and 12. If I want to find that missing side, I would create a proportion. I would put 2 over X equals 4 over 12. So 2 over X, I would do BA over ED is equal to BC over EF. And the reason I can do that, well, the triangles are similar. And if triangles are similar, then the corresponding sides of similar triangles are in proportion. That's why I do that. Now I cross multiply and solve. So I cross multiply and I get BA times EF equals ED times BC. And the reason is, in a proportion, I can cross multiply because cross products are equal. And whenever I'm proving multiplication, this is what it's going to look like. I know from my previous lesson, whenever I'm proving triangles are similar, there's only one reason, and that's angle is congruent to angle. So every single proof where I'm proving multiplication, it's going to look exactly like this. The only thing that's going to be different is the letters. We're going to work backwards in order to get up to the similar triangles. Let's get to our first example. It wants me to prove that SC times NK equals NA times SY. Well, we're going to work backwards. So I'm going to go to the bottom. I'm going to write SC times NK equals NA times SY. The reason for the multiplication is always cross products are equal. Before the multiplication, always is the proportion, because I can only get cross products if I have a proportion. Now, to create the proportion, I know when I cross multiply, the things that I multiply are diagonal from each other. So if I'm multiplying SC and NK, SC and NK must be diagonal from each other, and NA and SY must also be diagonal from each other. It doesn't matter exactly where these letters go, but they must be diagonal from each other. The reason for the proportion, always, for short, is CSSTIP. Corresponding sides of similar triangles are in proportion. Before the proportion, always, that ST is similar triangles. So I'm going to state that the triangles are similar. If it's obvious which triangles I'm proving are similar, great. In this case, I think it is. And make sure the letters correspond. So if I call the first one SCY, I call the second one NAK, because those letters correspond. A little trick too, if you look at the proportion, look horizontally and look vertically. Whichever letters make up the letters of a triangle, that's your triangle. So if I look SC and NA are not sides, do not make up sides of a triangle. If I look the other way, SC and SY, SCY, yes, that's a triangle. NANK, NAK, yes, that's a triangle. So it's not going to always be as obvious what triangles I'm proving similar, so you may need to look horizontally and vertically in your proportion to determine them. The reason for the triangles being similar, always, 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 is angle, angle is congruent to angle, angle. So I would make sure you have this written down or take a picture of it, whatever it is, because every single mini proof and every single proof for multiplication, it's going to always end exactly like this. The only thing that's going to be different is the letters are going to be different. The reasons are going to always be the same. The process is going to always be the same. It's just a matter of whatever the letters are. So I'm just going to basically copy and paste this into every single example. It's just, again, a matter of getting the right letters there. So we're just going to take a look at one more. I'm going to work backwards. CD times AE equals AB times CE. Whenever I'm proving multiplication, the reason is cross products are equal. Before the multiplication always, always, always comes from a proportion. The reason for the proportion always, always, always is CSSTIP. Corresponding sides of corresponding sides of similar triangles are in proportion. To put it into the proportion, whatever's being multiplied should be diagonal from each other. So CD and AE should be diagonal from each other, and AB and CE should be diagonal from each other. Before the proportion, always, 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 is your similar triangles. So I'm going to state that the triangles are similar. It's pretty obvious which my letters are here. DCE. Just make sure your letters correspond. So D and B correspond. C and A correspond. E and E correspond. Sorry, looks like we froze there. So DCE, BAE. Oh my God, I'm still frozen. No, I'm not. BA. Yes, I am. No, I'm not. BAE. The reason always, always, always for similar angle, angle is congruent to angle, angle. And that's the mini proof. So when you're doing an actual proof, you're literally going to do this first, and then you're just going to prove two pairs of things congruent, and then you'll have your complete proof. So let's actually do one more where the triangles are not so obvious which ones I'm proving. Let's take a look at number 6 here. There's a lot of triangles going on here, so I really don't know what corresponds to what. I really don't know which triangles I'll be proving just by looking at the picture. So I'm going to follow the process. I see that I'm proving multiplication. I'm going to work backwards. FC times PB equals DB times AC. The reason always, always, always for the multiplication, cross products are equal. Before the multiplication, always, always, always is the proportion. So I make a blank proportion. What's being multiplied must be diagonal from each other. So FC and PB should be diagonal from each other, and then DB and AC. And again, it doesn't matter exactly where the letters go, as long as the things that are being multiplied are diagonal from each other. The reason for the proportion, always, 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 proportion, CSSTIP. Yes, we have a song for this lesson as well, but I'm not going to go through the whole thing right now. That would be weird. Now, which triangles am I proving similar? I know it's going to be AA is congruent to AA. I know I'm going to prove triangles similar, but which ones? Well, we said earlier, look at the letters. Look horizontally, look vertically. Whichever direction makes up letters of a triangle, that's your triangle. If I go horizontally, FCDB, FCDB, that is not a triangle. So that was horizontally. Now let's look vertically. FCAC, that's FCA. Is that a triangle? Yes. DBPB. DBP. Is DBP a triangle? Yes. Those are your triangles, the purple and the green. So again, it doesn't matter how I name the first one, but the second one must correspond. So I'm going to go FCA. So what corresponds to F? Well, F is the right angle looking one, so I would say D corresponds. FC was the short side, so the short side here would be D to B. And that's it. So they usually don't give you ones where it's too complicated. Like, I don't think you're going to see one like this. But if you needed to, you would just look at the order of the letters, look at it horizontally, look at it vertically, whichever direction makes the sides of a triangle, that's your triangle. This is not a hard lesson. It's just a memorization and practice lesson. You're literally just writing the same thing over and over again. It's just practicing that so you know how to do it. That's all I got for you. Practice. Goodbye.